Alright, we're back with this thing. So this is my 74hc595 used with an Arduino or a microcontroller of some form. We're going with the Arduino today. I just bought some PIC stuff, some microchip PIC bits and pieces. So I'm going to have a play around with that. I've actually bought tons of these things before. I never got around to actually trying them out. We will look at that in the future. But anyway, we're going to continue with this. So yesterday I kind of went through the class structure. I probably should reiterate some of these things, except I've gone and forgotten, which is the first page. So we'll just quickly go through it one more time. So this was the stuff I was talking about with the ORs and the ANDs and the set bits and bytes. This is the class declaration here. So I say this is the class keyword and serial outs and some curly brackets. These are the things that are hidden within the class, and these are the things that you can access. So that the constructor can be accessed by other parts of your code. I just thought I might go quickly through and say one more time what a class really is. A class is a way of describing objects, and objects are things that sit inside the memory of your computer or microcontroller that have both, you can imagine them, like I said they do exactly, but you can imagine that they have both data components or bits of information inside of them, and also code components, things that operate on that internal data that they have. And so you have instances of these classes, and those are called objects. But hopefully if you're doing this, you kind of have a rough idea. If not, that's okay. We'll probably talk about these things more often. And there's so much stuff on the internet to find out about it. Which is the second page for this. So I had all these methods. I'm going to call them methods. You call them methods in Java, so I'm going to call them methods here. So the things that are attached to classes that you have bits of code that operate on the inside of things. They don't technically, like a method doesn't actually have to do anything with the actual class data. It could do something completely different, but that's kind of not a very effective way of coding things. If you're writing a function method thing inside of a class that doesn't actually do anything with regards to the class, probably that's not the best place to be putting it. So that's a good sort of way of looking at things. So there's a set OR, which is you set all the data specifically. So this class here has an internal byte of data, which is what it's going to pipe out to the 595. The whole point of this is simply to make it easy. So you have this nice consistent 8 bits of information that you can turn on and off individually, and then you let this class take care of the actual interacting with the IC in particular, which is this 595, 74hc595. But the thing I want to look at today, this is the bit that does all the work, the update method, is actually how do we use this. So this is the end of the class declaration, which is before we've actually used it. So today we're not going to talk about how you do things in C properly or C++ properly, such that you can use things kind of before, after, or before you've actually declared them. So we've declared this class here. We've typed it out and put it in the code, and that has to occur before we reach the thing we're going to use it, in the way we're doing it this way. Which is the easiest way of doing things, and most of the time it's fine for whatever you're going to do if you're making simple little projects on an Arduino. Right, so this is the code now that's going after that class, and this is the code where all the interesting, this is where we're actually going to use it. So this is the bit of code here where we're declaring a few extra bits and pieces that we're going to use in the rest of the code. So the big thing we're going to declare here is this pattern array, and I've labeled it as a capital letters because I'm treating it as a constant. So I'm following Java style conventions for naming things and how you put letters in places. So in Java you would normally write, and then in C you would usually write constants in all capital letters and use underscores for spaces to separate words. And even though these technically, well, that one technically is a constant, but this one is not a constant because I don't know how to declare a constant pattern, and it doesn't make any sense to have a constant array, because the array has to be stored on the computer anyhow. So technically you could change this constant by changing the array afterwards, but we're never going to do that, and I'm just reminding myself never to do that by putting everything in all capitals. And as you can see here, this is kind of a complicated, I was supposed to zoom in a bit, wasn't I? Alright, so that we're all on the screen. This is kind of a complicated piece of code stuff. Well, it's not complicated, it's different. So this is not a binary number, and the thing that's giving it away, and this is a bit, I wrote this a bit smaller in a smaller font so that it fit all on the page. It says 0B000, so that just means this is a binary number. So this is just all binary. It might have been prudent, but I didn't do it, to make these arrays using binary values instead, because then it would have been very clear as to what that was. But you might be able to see I might have actually used the pattern in here somewhere. I haven't. But this is just basically the binary values that I use to make the pattern. So if you look very carefully, this one here is all zeros, so this is blank, and then there's 2 in the middle. There's 2 on in the middle, and then there's 4 on in the middle, and then they're splitting apart and they're going away. So you get the sort of pattern where they starts off in the middle and then they zoom out, and then after that it goes blank for a few things. Actually it goes blank for quite a few, and then it does the opposite, so then it goes back in again. And in fact you can see that pattern showing up there's part of it, so we just have to go through the whole sequence now. But this is basically where this sequence is coming from. It's all, I've just created a whole bunch of numbers and they represent the pattern. This pattern is not part of it, but that opens up and then it goes back in. So those are the first couple of lines, and so that's what this is all about. This one here is just me saying how many what the size of this array is. So I'm saying there are 8, so each line is 8 bytes, and there are 8 of these bytes, so the pattern size is 8 times 8. And down here, this is the most important thing on this entire page, which is where we are actually declaring our class variable. So we've called it test, and we're passing into the constructor. So I'm going to have to bring back the constructor. So here is the constructor, and this takes the data pin, a clock pin, and a latch pin. Data pin, clock pin, latch pin. This is the constructor. And so test is passing in, for the data pin we're passing in 5, and for the clock pin we're passing in 6, and for the latch pin we're passing in 7. And if you look very closely at this, I might just turn it off so it's not glaring in there, I've plugged wires into 7, 6 and 5, and they are going straight into the various pins on the 74hc595. And if you don't know what those are, you have to go back and watch those videos where I painstakingly go through trying to use one of these ICs to do a silly little pattern thing. But that's all explained there, and that's just how I've decided. So this is the only point in the entire code where I've actually made any reference to the pins that I'm using and into the IC. So this is the only point where I've really made any reference to the hardware. It's just those 3 numbers there, and they're being passed in. And the important thing here is, now that we've got this class defined, we can in fact create another variable, and if we have another 595 attached to some other pins, so we've got quite a few pins here. We could attach like 3 of these at least. 4 of these we can have all the way up to 12. So going 0, 1, 2 could be one set, and then so on and so on and so on. I don't know. The only thing that I'm worried about is that you actually need, I don't think you need the pulse width modulation pins, so that doesn't really matter. So it doesn't really matter which pins you use. I'm using 7 here. It doesn't have a little squiggly line next to it on the microcontroller, so I'm assuming that one's fine, and that's the latch pin. So I don't see why it should. It's just that serial out thing. I don't know how that's coded. I thought it's serial out, which is a terrible thing. What I mean is the shift out function, so how that actually works. But you could always look up the source code and find out. In fact, we're going to write a shift out function very soon in an upcoming project for a very specific reason, as you will see, but we can save that for later. So now we've done this one. So now we've done that and we've declared it. So now we have a test variable and we've passed in those things, but it hasn't been initialized yet. Before we get to that though, we're just going to go through some functions, subroutines, functions that we've got within our code to do all the pretty pattern stuff. So the first one, and this is where it gets a little bit strange, is do pattern. And this thing takes a serial out object, but it has this little star after it. And that just means I want a pointer to a start, to a, and I do feel like I'm going to have to, in order to explain this, it's definitely going to need, which is my scrap paper one. I think this is my, the gloss, which is the scrap paper one. Well, this one is I think this is a scrap paper. This is a scrap paper one. Okay, so I don't even have any paper. Give me a second. Right. So I am going to draw it over here. You can imagine inside your computer's memory. This is the computer's memory. It starts up here at location 0. That's right. Okay, location 0, and this will be some other location down here, and I'm going to call that 100 because that way I can write it upside down. So I think that's going to be 001, isn't it? No, that's what it is for me. Right, I'm still doing that whole thing where everything's upside down, but I'm getting it right because my brain's thinking upside down, but then I think it's wrong because it looks right to me, because I think it looks like 100, but it doesn't because it looks like 001. But I'm thinking upside down. So anyway, and so when you declare, oh my goodness, this is going to get complicated. When you declare an object like this, a variable which is a class, which is an object, a variable of a type, which is a class type, which creates an object called test. That will end up somewhere inside your computer's memory. So this will be, sorry, it's going to be upside down for you. I can't write upside down. So test is in here, and so it starts at some particular memory location, probably here, and it finishes at another memory location, and the computer knows this, right? But this is when you declare this, you declare this whole chunk of memory that sits here and is being used specifically for the test variable. But you can't really pass those things around to a function, because then it would have to make an entire copy. It would have to make an entire copy of my test variable. So say I have a function and then I call something, and you're passing this thing into here. You may have to create an entire copy. When you call a function normally and you pass in the value 1, you make a copy of the 1 into another variable, and then if you change that variable within that function, you don't change the original value that you passed in. I don't know if I can explain that, but look it up online. There's tons of resources. But I'm going to quickly go over it because I want to explain, where is the line, why I pay the star thing. So the star thing in C just means I don't want the actual object. I just want a pointer to that object or a reference to that object. So what you're passing in is you're passing in the value which represents. So this might be, okay, I can do this, 50. So this is location 50 in the computer's memory, byte number 50, and this is where test starts. So when you're asking for this, you're basically just passing in the value, which is the address in memory, the computer address in memory, for whatever you want to use, whichever serial outs object you want to use. And then you're also passing in here a delay time. And what this is basically going to go through is it's just going to go through all my patterns. It's going to set the byte, the internal data byte for my serial outs object to that pattern. Then it's going to ask that outs object to update the actual 595 IC. So we've set the value, we update it, and then we wait the delay time, and that's what's going to create that pattern. So we're going to go through every single one of those patterns and that's going to essentially create an animation. Except I don't know where I put the piece of paper which had all the oh, here it is. It's going to go step through each of these in turn, and it's going to create an animation effect, and so that's how you get this little pattern thing. But you could do this on several different you could call this with a different serial outs object if you wanted to use something with different pins. And so now we have also got this one here, which is do point test. What does that one do? Oh, that just does one particular point. So for a particular set, so do point only works on test. I don't think I actually use this. I hope I don't use this. So you can kind of forget that one. Oh no, actually, so the rest of these ones actually directly refer to test, and this is important. So test, just to remind you, is the name of the variable, which is the serial outs that we're using in our code. So this bit of code here is more generic and is designed to let you pass whatever serial outs object you want to pass in. This one here specifically uses the test that we have declared previously. And you may notice something big and important and different is that here, wish I had a different, I do have a different color, is that we are in fact got a dot, so it says test.set, whereas up here we're using outs, and we've got this funny little arrow symbol and then set all, or we're calling, so when we call the methods in this case we're using the minus an arrow, or the little arrow symbol, and in this one here we're using a dot. And this is where things are kind of annoying in C++, and in Java, for example, you wouldn't have to ever care about this because everything is essentially by reference, as they say, not forgotten the term when you do it this way. But the reason here is, in this case here, because you don't have the star, you're declaring an actual test object, and that's what this variable is. It's the entire object. And when you're referring to something that's just the entire object, you use the full stop symbol to call the method. So you go test.fullstop set, and that's fine. But when you're using a pointer to something, you want to say you have to use the arrow symbol to call the methods, which is annoying, but it does make, it made sense when C was first developed. I feel like now these things should just work out which is which automatically. They already know what this variable is, so I don't know why anymore they do these things. I mean, I'm sure there is a reason, but I always, every time I write in C, I'm just like, well, I'm just going to write my own systems language that doesn't do anything. This just basically C. It's real simple. It doesn't have anything else, but it just doesn't have all this quirkiness because it's really annoying. But of course, that's what Go and stuff is. So maybe we should switch to Go. Not that we're coded in Go, but this is the thing that's going to trip anybody up whenever you're doing C code, C++, and you've never done it before, is the difference between why do you use the arrow thing and why do you use the full stop. And the only way to do it is just to write your own code and and you'll eventually work it out what's going on. But because so the remember thing here, it's going to be a full stop as long as I've declared, I'm referring to a declared variable where I've declared the entire object. And I'm not using a pointer to an object. If I'm using a pointer to an object, then I'm going to use the arrow thing. So the thing that will come into that is, why do I say this arrow here? Because this case here, this is a pointer. This magical created variable called this is in fact a pointer to yourself. So in here you have to use an arrow symbol because this is a pointer to this object. It's not the object itself, it's a pointer to the object, which is also going to cause brain problems. If you do Java, then it's always just full stops, and it's not any different because there isn't any. There's only the pointer by pointer version. But anyway, down here we've got the do point. So this just sets the point for a second, for a fraction of time, which is 100, and then it clears it straight after that. So the whole idea is I'm going to go through here. So if I want it to go backwards and forth, I go from 0 up until 7, up until 8, but not including 8. So 0, 1, 2, 3, 4, 5, 6, 7, and I set that point as I go along in my loop. So first I just clear everything, and then I go through and I do point. Point will set that on, so when you start off with 0, it will make the point come on, and after a fraction of a second it will turn it off, and then the next time it will go around, it will turn the next one on, and that creates this creates a pattern where you just go through each LED in turn, which you do see, which we'll go back to in a second. And then we've got here, which is the reverse, which has the same kind of loop, but in this case here I'm going to be setting it to 7 minus I. So instead of setting the point that I'm turning on to being I, so the first one will be 7 minus 0, which will be 7, and then 7 minus 1, which will be 6, and so on and so on, and that will create a backwards effect. Normally I do the loop backwards like that, the other way around, so I start at 7 and then I go down to 0. But the way I normally write this is you say, as long as I is greater than or equal to 0, but because these are unsigned bytes, I'm not going to go into this, but because this is an unsigned byte, that trick doesn't work, because I is always going to be greater than or equal to 0. Because if you have 0 and you subtract 1 from it, you actually end up with 255 because they're bytes. And so if you were doing it with signed bytes, then you would subtract that, you would get minus 1. But that's for another day. This is an empty semicolon that goes at the end of that one. And so this is the last bit of code. We've got 7 minutes left. The first thing we do in the setup, so this is your standard Arduino code. We've got a setup and a loop. And the first thing we do is we initialize our test variable, and because we're referring to the test variable, which is itself and not a pointer to an object. It is an object, not a pointer to an object. We're using the full stop. And then we've got the loop thing, and that's going to call back and forth, which is the one which just makes it go one way and then back again. And then we're going to call the do pattern thing, and this is the very last and exciting part. And in fact I'm going to bring it right up to the camera, is this use of the ampersand symbol. And so this is when we have to move between the two ways we understand an object. So either we're referring to the actual object itself, or we're referring to a pointer to itself. The do pattern thing, just to emphasize it one more time, doesn't take an object, it takes a pointer to an object. That's what the star means. And so we have an object, that's what the test variable is, it's the actual object. But we want a pointer to the object to pass into this, and that's what the ampersand symbol means. That means get the pointer to this object, and that's what we're going to end up with. So we're getting the pointer to test, and we're passing that into here, and that thing wants a pointer to a serial outs object, and it will get one as long as you have the ampersand. If you don't have the ampersand, the compiler will say, no, you can't do that, there are different types. That's a pointer to something, and this is an actual thing. You can in fact pass in pointers to numbers, and pointers, so you could pass in like a pointer to, you could have a variable that's not an object, so it could be an integer variable, and you could pass in a pointer to an integer variable, and then you could change that variable. But I'm not going to go into that. So that's more complicated stuff, and probably beyond the scope of this channel, because I don't want to go too much into coding, but I'm sure I'm going to come up with a way of actually illustrating why you might do that, and what I'm actually talking about. But anyway, I'm going to finish it for there, but we're just going to go through one more time, just to check that this is actually doing the same thing. There are two sections to the lights. There's one bit where it goes backwards and forth, and I did the back and forth thing to show the use of the set a particular value, a particular pin on or off, and then the pattern sets everything at once. So hopefully you can see it. So it should start off and do the backwards and forwards first. So there's the backwards and forwards, and then there's the pattern sequence, and it's just going through all of the different patterns. I've lost the piece of paper with the pattern thing on it. And then it's doing that. There's a whole bunch of little random things, and then we're back to the backwards and forwards, and then we do the whole pattern thing over again. So that's not a very exciting use of this, but it will come in handy later on, because now we've turned 3 pins into 8 pins. And the beauty of this code is written just for one 595, but you can actually daisy chain these things together. So you only really need, if you're going to have 2 of these and you're going to have 16 LEDs or 16 outputs, you only need 1 extra wire, because they can all share the same clock and they can all share the same latch clock. But the only thing that's going to, oh no, they don't, they share the, no, you don't even need another wire. What am I talking about? You can actually create, so from 3 wires you can actually get 16, so that the clock goes through, because you can take the last thing shifted out of this thing and shift it into the next one, which I haven't gone through, but it's really handy if you want to have lots of extra outputs. So that's one thing. We're going to use this in a couple of other projects soon. So we are going to use this in that Pong project where I used a 4017 to create a similar effect, kind of. But we're going to use that for the game indicator lights, so we're saying who won the last game and that kind of stuff. We're going to use a 74hc595 in order to do that kind of things. And maybe it'll have a little score counter as well. And we're also going to do, coming up soon, is going to be a series about a very simple game, which is that one where you have the river crossing game. So it's going to be kind of a beginner's project, but also it's going to lead into some basic electronic stuff. Where we do the river crossing, we have like a farmer, and then they have like a cabbage and I don't know how it goes, a cabbage and a chicken or something and a fox, and they have to cross the river, and you can't leave certain things with each other at the same time without the farmer being there, otherwise they eat one of them will get eaten. And we're going to go through and we're going to make that first with this thing, and then we're going to make it with logic ICs. So that should be fun, but that's going to come into this because I want to make it using a smaller version of an Arduino, a tiny 85, which doesn't have any outputs. So we're going to be using ICs to support that thing. So that's where this is going to come into it. But thanks for watching, and I'm going to have more videos soon, and they're not going to be about this, they're going to be about joysticks again. But we are going to come back to what I just talked about in a while. But thanks for watching, and like, share and subscribe.